Back in the dress.
Okay, this is page 2. I just want to highlight a couple of problems. Today, we're just going to go through and work through worksheet 2, but just want to highlight a few problems from your homework. So we need to just be able to recognize that whenever we see a log problem, that we're always looking to expand, right? So we always want to consider, okay, what expansion can I take care of first before I think about my derivative rule? And then once I have my expansion fully taken care of, then I can think about, okay, log base 8, that's log base A. It's basically u prime over u with a little bit of additional coefficients. Number 8, we have a to the u and we have log base A, but these are being multiplied. We have to understand, okay, I got to go through product rule for that. Number 9, expansion first. Anytime we see an exponential function, we know there's no expansion that we can do. It's not within a log function, so we just have to jump directly into our derivative rule. So this is a to the u, which is natural log of a times a to the u times u prime, and u prime is a little bit messier because this is the exponent is a function within a function. We got to go through chain rule just to handle that u prime there. We did 11, and then number 12 is tangent line equation. So we need to be able to do that as well on the quiz. So tangent line equation, all that is you go through the same process. You find the derivative, whatever it takes to get the derivative, plug in the x value to get the slope. Once you get your slope, take your order pair and your slope and do point slope form. Okay. Any questions with worksheets? I mean, page 1, worksheets, worksheet 1, page 1 and 2. All right, so today we're going to work on worksheet 2. Okay, start at the top. Natural log problem. Again, anytime we see natural log or log, we're always thinking expansion first. So rewrite that first as a rational exponent, and then see what rules you can apply to get it all expanded out, and then you can think about your derivative rule. Okay, so number one, we rewrite our radical as to raise to the 1/5, bring that 1/5 down, continue expanding natural log of a minus natural log of b. That 1/5 is going to see both the natural log terms. So once we have it all expanded out, u prime over u for both. And you don't have to worry about cleaning up. If you don't clean up, I'll still give you full credit. So sorry, any questions with one? Okay, number two, we first rewrite the function with irrational exponent form. So this is 3 plus 4x squared raised to the 5 over x. That's our first step. From here, we should be able to recognize, wait, this is a little bit different here because that parentheses has a variable in it. That base has a variable in it. The exponent also has a variable in it. So this is a variable raised to a variable. We don't have a rule that can handle this, so we have to go through what? What process is required? We got to take the what of both sides. Yeah, natural log of both sides, right? So this is log differentiation, and I will indicate that to you on the quiz. Say, hey, this is hence use log differentiation for a problem like this. So variable raised to a variable. We always have to find a way to get that exponent to be in a different location. So to do that, we take the natural log of both sides, which opens up our log property. We can bring that exponent down. And once that exponent comes down, then we can explore our derivative rule. Left side is always implicit, and the right side is always product rule that has to be applied. So try that. We know that natural log of y is always going to produce a 1 over y dy dx, and the right side is just identifying the appropriate derivative rule. 5 over x is more easily thought of as 5x to the negative 1. If you leave it as 5 over x, you got to go through quotient rule, but we talked about how anytime your numerator or denominator is missing a variable, we can always bypass quotient rule by just bringing that denominator up. Or if it's x over 2, you'll make it 1/2 x. But yeah, anytime your fraction is missing a variable, either numerator or denominator, we should always be able to just rely on power rule. There's no need to go through quotient rule. Okay, so f prime g plus f g prime. And then once we have our derivative, our final cleanup step is moving the y over to the right side, replacing the y back in terms of the original function. And then there's our derivative. Questions with 2. Right, number 3 and 4 are the inverse function problems where you have to go through your chart to kind of work your way through. So try 3 and then try 4.
Okay, we're trying to find f prime of 6. I'm going to put that in the bottom corner here, and I'm working my way around my graph. We can always start off this way. This is always going to be our pattern, even before we look at the rest of what's given to us. Now I'll just fill in the rest of the chart in the first row and then move down to the third, that third space. So we have something that is not going to be useful for us, right? That g of 6 equals 3 doesn't fit our problem. It's g of 3 equals 6. That's going to be helpful for us. And then we can find g prime of 3. And that number will lead me to the slope of the f graph at 6. Okay, number 4. Same process. There's a little bit more work involved because we have to find the order pair on our own and go through power rule to find the derivative. Okay, we know negative 15 is the x value of our inverse function, which must mean that negative 15 is the y value of our function. So plug negative 15 into the y variable of your function, and then go through a series of guess and check to figure out what x value works. Start with 0. If 0 doesn't work, try 1. If 1 doesn't work, try negative 1. Two gives me, let's see, 8 minus 8. Doesn't quite work, but what if we try negative 2? So negative 8 minus 8 is negative 16. Negative 16 plus 16 is 0. Okay, so now we know x equals negative 2 works. So if I can find f prime of negative 2, then I can use that to get to my answer. So find f prime of x, find the slope of the f graph, find the slope of the f graph first. The derivative function, and then plug in negative 2 to get to the slope, and then your reciprocal will get down to your answer. So my derivative is just 3x squared minus 4x. Plug negative 2 in, I get 20. Take the reciprocal, my answer is 1 over 20. Number 5, we have a log function, but we treat it like natural log, right? At the beginning, just go through your properties, expand all that you can, and then your derivative rule for log base A is a little bit different. Still u prime over u, but it's a little bit of extension in front. So this is all the expansion steps that I took. After this, we can jump into our derivative rule. Again, once you find your derivative, you don't have to do all the cleanup. Okay, next page, try number 6. We see two functions being multiplied, so hopefully that reminds us we got to go through product rule there. And these are the two new rules, extensions from natural log and e to the u. We have log base a and we have a to the u. Okay, f prime g plus f g prime. 3 to the 4x is very much like e to the u times u prime with a little bit of conversion in front. And then log base a of u is u prime over u with a little bit of 1 over natural log of 4 in front. Okay, any questions with 6? Okay, number 7 is also log differentiation. I just want to point out that on the quiz, you're not going to use log differentiation unless I specify that you do. Okay, so I don't want you to try log differentiation if I don't specify it. So for number 7, though, there's that instruction. So take the natural log of both sides, go through all your expansion steps on the right side. One over y dy dx. Well, once we expand everything out on the right side, 1 over y dy dx is our slight implicit that will show up. And then we bring that y over to the right side, replace the y back in terms of x. Any questions with 7? Okay, number 8, find the derivative. 3 things that I want you to point out about this problem. What's involved in this process? Let me see. Product rule. Which part? Product rule derivative is only once. Where is that going to show up? 4x1. Yeah. So there's product rule for derivatives. Okay, good. All right. What else do you see? Product property. Yeah. There's a natural log expression with multiple things in it. We also want to take care of product property. In fact, that should be the first thing that we do, because that way we can get that out of the way before the derivative hits. And there's one more thing to point out. Okay. Yeah, the derivative will just naturally force that 7 to be 0, right? But something else. What's different about this equation? What do you notice about the variables? Yeah, there's multiple y's, right? It's mixed into the equation. So we got to go through implicit, right? We got to keep track of our dy dx's. There's going to be more than one that's going to show up. Okay. All right, so start here. Start with your product property. get that natural log, expand it out first, and then you can move into your derivative process. Okay. How many dy dx's do we expect to see for number 8? 2, yeah. So this is as far as I can expand. Now we can think about product rule for that 4xy, f prime g plus f g prime, as well as keeping track of our dy dx's along the way. 4x becomes 4. We keep the y. 4x is still 4x. Y derivative is dy dx. Natural log of x is just 1 over x. Natural log of y is 1 over y dy dx. Careful, that 7 also gets affected. And once we get our derivative equation all set up, then it's just adding and subtracting, collecting your dy dx terms. Factor the dy dx out. Number 9, find the tangent line equation. So if we can just get to the derivative, plug in the x value, get our slope, and then do point slope form. Okay, try number 9. There's a little bit of product rule there, x times e to the x. After we spell that product rule, we know e to the x is just e to the x. Find the derivative or find the slope, plug 1 in. E to the first power is just e. My slope is just that numeric value e and point slope form. Okay, any questions? I'd like for us to practice memorizing these rules. Well, first off, you're going to have to make sure you memorize product property, quotient, and power property. But hopefully, we've done enough of these where you feel pretty good about them. But I want us to memorize, practice memorizing these rules as well. So natural log of u is u prime over u. E to the u is just e to the u times u prime. We know that log base a of u is essentially the same process as natural log of u, very similar. Just a little bit of extra in front. And then e to the u and a to the u are very much similar as well. Original function times exponent's derivative with a little bit of extra in front. And if you have trouble remembering where that natural log of a goes for these two, if you see something in the denominator with the base rule, then you know the natural log of a also is also going to go in the denominator. Here, the a to the u times u prime has no denominator presence, so that helps you remind yourself that there's no that natural log of a will go in the numerator. So give that a few seconds. I'm going to cover this up, and then I'm going to have you just use any space that you have to see if you can practice writing out your list. Everything they can get it. All right, get better time. Okay, this is our first time through. We can try it again tomorrow. So natural log of u is just u prime over u. E to the u is just e to the u times u prime. We let that be our guide, because we can just build our new rules from those, right? So log base a of u is still u prime over u, but with 1 over natural log of a in front. A to the u is still the original function times exponent's derivative, just with natural log of a in front. Your homework is just worksheet 2. So we finished it all. So tomorrow I'll just walk around and check you guys off for that assignment. Now, we do have I think with this quiz, we have the luxury of having an extra day when I think most of us are pretty ready. So I would like to try this tomorrow. Tomorrow, I want us to treat worksheet 3 as a mock quiz. Okay, so you'll put everything away. You will basically, you're taking a quiz without any consequences, and I'll walk around. You can ask me questions. I can also check your progress. So tomorrow we'll do this. Tomorrow we'll review our rules. You'll spend 5 minutes reviewing worksheets 1 and 2, and then we'll spend 30 minutes just having a mock quiz environment, see how we do. And that way, you know, if there's any issues, you can get all those figured out. And then Friday, you should feel really good for Friday's quiz. Okay, bye, come get your phones. That's right.
So why don't you like us?
You can pick the grades in class here, or tomorrow, or if not, you can take it Monday. You can choose
Tomorrow only.
tomorrow, Monday.
Okay. Thank you. Thank you, Mr. Morris.
Yeah. Do you need help with help sessions or? I think so, okay. You just want to retake the quick test just so. 7:15. Okay.
Pretty much for me. Yeah. So